Welcome. In this video lecture, we are going to discuss examples involving calculation of limits by L'Hopital's rule method. So here are the examples. So evaluate the following limits. So the first one is limit as x approaches 0 of 3x minus sine x over x. So as I told you in the first lecture when we were introducing the two theorems involving the L'Hopital's rule, you must always test that the functions you have satisfy either this property or this property. One of the indeterminate forms 0 over 0 or infinity over infinity or negative infinity over infinity. If that condition is not satisfied, then forget about applying L'Hopital's rule. So solution here. So when you put 0, we'll have 3 times 0. The first thing you test, minus sine 0 over 0. 3 times 0 is 0, minus sine of 0 is 0 over 0. 0 minus 0 is just 0 over 0. So therefore, it satisfies the first indeterminate form 0 over 0. So therefore, L'Hopital rule can apply. So, so solution. And one thing that you need to remember is that we are not using now quotient rule to do the derivatives. We are just differentiating the numerator function differently and also the denominator function differently. So don't confuse by quotient rule. So this will be limit as x approaches 0 of 3x minus sine x over x. So the same as the limit as x approaches 0. So you differentiate numerator differently. So this will give you 3 minus cos x. And then when you differentiate x, you get 1. Please don't confuse this one with differentiation by quotient rule. Quotient rule does not apply here. So there now, when at this point you can use direct substitution, the 3 minus cos of 0 over 1. Cos of 0 we know is 1, so it'll be 0, 3 minus 1 over 1, which is just 2. So therefore the value of that limit is 2. Example 2, limit as x approaches 0 of square root of 1 plus x minus 1 over x. So the first thing you have to test that the functions you have satisfy the one of the two indeterminate forms, 0 over 0 or infinity over infinity. Don't just start differentiating without testing. So here we have 0, 1 plus 0 minus 1 over 0. So 1 minus 0 is 1, square root of 1 is 1. So 1 minus 1 over 0, the same as 0 over 0. So it's true that this is the case of 0 over 0. So therefore, L'Hopital rule can apply. So you say limit as x approaches 0 of square root of 1 plus x minus 1 over x will be the same as limit. At this point, you are expected to be knowing how to differentiate functions. So the derivative of this one will be given by a half 1 plus x raised power minus a half. This is just constant, which will be 0, over the derivative of this one is just 1. So here we use direct substitution. We have a half into 1 plus 0 raised power negative a half over 1. So just be a half over 1, which will just be a half. Example 3, limit as x approaches 0 of square root of 1 plus x minus 1 minus x over 2 over x squared. So here you have to test first before you start doing the process of L'Hopital rule. So you'll have square root of 1 plus 0 minus 1 minus 0 over 2 divided by 0 squared. So this will be square root of 1, so 1 minus 0 over 0. So this will be 0 over 0. So indeed, it is satisfying one of the correct indeterminate forms, 0 over 0. So therefore, the next step, we will now to differentiate the functions independently of each other. We are not applying the quotient rule. So x squared. So this will be the same as limit as x approaches 0. So when you differentiate this one, you get a half into 1 plus x raised to power negative a half. This will be 0, and then this will give us minus a half over 2x. Now, we can always, once we have done that one, then try to do direct substitution to see whether it works. So we'll have a half into 1 plus 0 raised to power negative a half minus a half over 2 times 0. So this will give us 1. 1 times a half is a half minus a half over 0. Half minus a half is 0 over 0. So this is still the case of 0 over 0. So you also repeat the same process of L'Hospital's rule. So we repeat L'Hospital's rule. So we repeat the rule by simply also differentiating the functions to see whether the new function that we get will give us a function whose limit will be easy to evaluate by substitution. So differentiating this one, will get negative 1 over 4, 1 plus x raised to power minus 3 over 2. This will just be 0, and then over 2. So here now direct substitution will have negative 1 over 4 into 1 plus 0 raised to power negative 3 over 2 over 2. So this will be 1. So have negative a quarter divided by 2, which will be negative 1 over 8. So this example illustrates a case whereby you can apply L'Hospital rule more than once. And then D, another example, calculate the limit as x approaches 0 of x minus sine of x divided by x power 3. So the first thing you have to test to see whether the correct form of the indeterminate form, the functions you have satisfy that. So you have 0 minus sine of 0 over 0 cubed. So 0 minus 0 will be 0 minus 0 over 0, which will be 0 over 0. So this is the case of 0 over 0. So L'Hospital rule works. So we'll have limit as x approaches 0 of derivative of this one will be 1 minus cos x, and then divided by 3 x squared. Now you try to do direct substitution to see whether the limit exists. So we'll have 1 minus cos of 0 over 3 0 square. So this will be 1, cos of 0 is 1 over 0, so 0 over 0. So you see still this is 0 over 0 case. So we repeat L'Hospital rule. So apply L'Hospital rule again. So it will be limit as x approaches 0. Now this one is minus sign, minus minus positive, so we have sine of x over, so this will be 6x. Now you also try to see whether now this process will end here. So 6 times 0. Sine of 0 is 0, 6 times 0 is 0. So this is still the case of 0 over 0. So because it satisfies the hypothesis of the L'Hospital rule, then you also apply L'Hospital again. So apply L'Hospital rule again. So we have limit as x approaches 0 of sine. So when you differentiate sine, you get cos. So cos of x, this would give us 6. Now, direct substitution at this stage will have cos of 0 over 6. Cos of 0 is given by 1. Cos of 0 is 1, then 6. So therefore, this limit will be 1 over 6. So we'll stop at that point. So then last, consider this example. Limit as x approaches 0 of 1 minus cos of x over x plus x squared. So for this case, let's see whether you can apply L'Hospital rule. So we have 1 minus cos of 0 over 0 plus 0 squared. So this will give us 1 minus 1 over 0. So 0 over 0. So at this point, you are allowed to use L'Hospital rule because it's 0 over 0. We'll have limit as x approaches 0 of this one. Now will give us sine x because now this is negative. So we have 1 plus 2x. Now, you might be tempted now to, let's see, you might be attempted to apply L'Hospital rule here, but please, before you do that one, try to see whether it applies or not. Because we have sine of 0 over 1 plus 2 times 0. So this will give us 0 over 1. So remember, 0 over 1 is defined. So therefore, don't now. So therefore, this is 0 over 1, which is just 0. So 0 is the correct answer. So in this question, please don't be tempted to reapply L'Hospital's rule to this limit, x approaches 0 of sine x over 1 plus 2x, by saying that it will be now limit as x approaches 0. When you differentiate sine, you get cos. When you differentiate here, we get now 2. And then you say now you replace cos of 0 over 2, then say a half. If you do this one, the answer you have will be wrong. So all this, if you are tempted to do this, this gives you a 0. So therefore, the correct answer for this limit is just 0. So before you are tempted to apply L'Hospital rule, ensure that you test the case of 0 over 0 or infinity over infinity. If that condition is not satisfied, please, my friend, don't be tempted to apply L'Hospital rule. Thank you.